We are talking about parallel lines and proportional parts, and we want to be able to use proportional parts with parallel lines. So here we have a corollary to the triangle proportionality theorem. If three parallel lines intersect two transversals, then they divide the transversals proportionally. So we have three parallel lines, and all three lines are intersected by this line and also this line. So all three of these parallel lines are intersected by two transversals. So it says if AE is parallel to BF is parallel to CG, then it says AB divided by BC is equal to EF divided by FG. And we can do this the same way that we did with the triangle proportionality theorem. We can draw the proportion right on our screen or right on the paper. So we put our proportion right there, and basically it says AB divided by BC is equal to EF divided by FG. Also, AB divided by EF is equal to BC divided by FG. So we could draw the proportion to go also this way. We could also set up the proportion where we talked about the whole thing, AC divided by BC is equal to EG divided by FG. So basically, as long as we're comparing the same parts and we have our proportion set up correctly, everything is going to be proportional. We'll look at some examples later. We also have the triangle or the midsegment of a triangle. So the midsegment of a triangle connects the midpoints of two sides of a triangle. So right here it says if RP is parallel to CB. So we have RP, which is right here, and that is parallel to CB, which is right here. Then RP is equal to 1/2 of CB. And this makes sense, hopefully, that RP is going to be smaller than the full thing, CB. And then the relationship of 1/2 is calculating the average. So triangle midsegment theorem says a midsegment of a triangle is parallel to one side of the triangle and is half the length. So if this is the midsegment, then we know that this line is parallel to this line, and this line RP, this line segment RP is half the distance of CB. And we can fill in 3 more there, or 2 more. So if we have RQ, which is right here, RQ is going to be parallel to AB. Line segment RQ is parallel to line segment AB. So we're going to use these same 2 again. So it's going to be RQ and AB. Now, which one is smaller? Well, AB is bigger. So we have to cut AB in half in order to make sure it's equal to RQ. So if we put 1/2 over here with AB, then they will be equal. And we have one more to look at. We have PQ, which is right here, and AC. And those are parallel. So PQ is parallel to AC. And the two distances that we're talking about distance PQ and AC. Which one is bigger? Well, AC is bigger. So AC has to be cut in half in order to make sure that it's equal to PQ. So some things that we can add. If this is cut in half and PQ is half this distance, we can add two congruent marks right there to match the existing two. And this one's cut in half because these are both congruent. AB is cut in half. So RQ is congruent over there. And then the last one we have where CB was cut in half, and this one has three congruent marks on it. And because RP is half the distance, this is also congruent.